Kia ora team and welcome to another online tutorial. Today we're going to be talking about mass and restoring force and springs, again continuing on with oscillating systems or simple harmonic motion. Much like when dealing with pendulums or simple pendulums, we have a restoring force that is acting towards the point of equilibrium. If we look, we can see instead of having our equilibrium as a central position between lateral movement, it is now a central position between vertical movement. Okay, we will oscillate about that equilibrium, with our amplitude or displacement being our extension or compression of the spring. Okay, our equation when calculating this force or the restoring force within a system such as this is F equals negative Ky, where F is our force measured in newtons, K is our spring constant measured in newtons per meter, and Y is our extension in meters. From this equation, we can gain that F, our force, is proportional to our extension or displacement. The negative sign in our formula indicates that force in the spring and the spring's extension act in opposite directions, okay? And the force is always accelerating the mass towards the equilibrium. So it can act positively or negatively depending on its position within its oscillation, hence why we have a negative, as it can go both ways. We measure the extension x from the equilibrium position, allowing us to use Hooke's law to calculate the force applied, which for us in a system undergoing simple harmonic motion will be our restoring force. Cool. Let's have a look at free-body diagrams, or the forces acting on our mass in different positions, or different frames of reference in its oscillation, okay, as well as the velocity, acceleration, and displacement or extension of said mass and how they relate. For our reference frame A, when our mass is in the equilibrium position, forces on said mass are going to be balanced. Those forces being our F spring and force due to weight. The force due to weight being constant across all our reference frames, as the mass of our object does not change and gravity is constant. So I'm going to mark those on. For our second reference frame, our mass is below the equilibrium as extended to our max extension, x, okay, meaning there will be a larger force applied by the spring, with that restoring force acting toward our equilibrium. For our third reference frame, our mass is once again in the equilibrium position, meaning that our weight force and force due to the spring or applied by the spring will be equal. For our last reference frame D, as our object has moved past our equilibrium, okay, our spring has compressed, we have a negative extension, we're going to have a smaller force acting from the spring. In this case, our restoring force will be the force due to weight minus what force is applied by the spring. With A and C being balanced and B and D being unbalanced, although in different directions. Let's talk about our extension, velocity, and acceleration. Our diagram here not being in sync with or to scale with the one above. Okay. Y showing our extension, okay, V showing our velocity, and A showing our acceleration. As the mass has dropped and our extension increases, our velocity will be transformed into elastic potential, This elastic potential will then be transformed into energy kinetic, and we'll get velocity in a different direction, with our highest velocity being while moving through our point of equilibrium, and our lower sections of velocity being when we are at maximum extension. Acceleration being inverse to that, when we are at our central location or equilibrium, we have no acceleration acting. As our velocity is being transformed into energy potential, we have deceleration. As our energy potential is being transformed into energy kinetic, we have acceleration, and so on. In summary, when we have our greatest extension, we have our highest acceleration but lowest velocity. When moving through or at the point of equilibrium, we have our lowest acceleration, highest velocity. Very similar to with a simple pendulum. Hopefully that has helped you understand the role of restoring force for masses on a spring, how to calculate force and its proportional relationship with extension, the forces acting on an object depending on its frame of reference regarding its oscillation, and the relationship between extension, velocity, and acceleration. Hopefully this helps you get out there, get into some physics team. Good luck.